Okay. So I'm recording.
Thank
Don't
you,
mind
sir.
me. So that is it. So those are short terms, right? Now we treat
Yeah.
short term. We treat short term just the same way we treat variables in algebra. What do I mean by that? Let me explain. Before I will solve the problem, but let me just break down some fundamental concepts. In algebra, there are variables that are called like terms, and we
Okay.
also have unlike terms, right? Like and unlike terms. X, if I have two terms, two algebraic terms, 2x and 5x, for instance, these two terms are like terms. Why? Because they have similar variable y. I mean, similar variable x. I can add these two terms up by simply adding the coefficients 2 plus 5. And what is 2 plus 5?
7.
7. So 2x plus 5x will be 7x. In similar manner, if I have 2 root 2 plus 5 root 2, for instance, I will add the coefficients. So I'm going to see root 2 as a variable, right? And then I add the coefficients to get to this as 7 root 2. Does that make sense? Please, does that
Okay.
make sense? Am I communicating?
Yes. Yes, sir.
That is one thing you
Yes,
should know
sir.
first. Good. That is one thing you should know. Treat the short term as variables. Just like I treated x as variables, so I added 2x to 5x to get 7x. And I'm adding short terms, 2 root 2 plus 5 root 2 will also give 7 root 2. Now, in algebra, since I cannot add these two terms, 2x plus 3y, because they are unlike terms, I can't add this to have to obtain 5xy. That is wrong. This is going to be wrong. If I say the answer is 5xy, it is wrong. They are unlike terms. Okay. I can't simplify for that. The final answer is going to be left like that, 2x plus 3y. The same way for sod, if you have two short terms such as 2x plus say 3, sorry, 2 root 2 plus 3 root 5, these two are unlike terms. Even if the coefficients are the same, even if it is 2 root 2 plus 2 root 5, they are still considered unlike terms because the values under the square root sign are different. You can't add further. You can't add these two things. This is the final answer. The best thing you can do in this situation, because they have the same coefficient, is to factor out the coefficient so that you have your answer as 2 into 2 plus root 5. These two terms cannot be added together because they are unlike terms. Please, does that make sense?
Yes, sir.
All right. Very good. So that is the first thing you need to know about sword before we begin solving sword. You have to understand the terms that we consider like terms and the terms we consider unlike terms. And you have to also understand that like terms can be added together, but you cannot add unlike terms together. Okay. Now, with this simple explanation that is given, let's go ahead and solve this problem. And please, as I'm solving, remember this is not the regular class where everybody be muted and nobody's asking questions, even if they don't understand some concepts. Please, if I say anything or I take a step that is not clear to you, stop me and ask me questions. I would answer. I want us to interact. Okay, just the same way I used to beg us during the normal live sessions that let us interact. People will be shy to say something. In this class, don't be shy. We are very few here. Okay, so if anything will happen, the worst thing that can happen is maybe Anna will laugh. She will laugh at me and say, "Okay, I've said rubbish." But that will not take out one strand. A strand of air will not leave my body. If she likes, she should laugh. That will not affect me, right? So, Olakunle, if you have questions, ask. Oh, Augustina, if you have questions, ask. Oh,
I will ask, sir.
don't
I
allow
will
Anna to
ask.
meet you with her laugh. Christina, ask your questions. Okay. So let us, Anna, don't mind me. I'm just being naughty. So let's continue here. I had to change my board because
No problem.
the other board is misbehaving. So I have changed my board. Do you guys notice anything? Do you notice I just
Yeah.
changed my board now? Aha. That other board is misbehaving, it's making my handwriting look horrible. So I just decided to move on to another board. Solution. Okay, so we have 7 plus root 5 over 3 plus root 5. Before I go further, I want to also mention another concept. It is called rationalization. Rationalization. I believe you must have heard this term for those of you that have gone through the class, right? To
Yes.
to rationalize simply means to make a an irrational sword becomes a rational sword. And how do we rationalize the denominator? So our focus is usually the denominator. So whenever you see this question here, this question that says express this fraction in a form of this, right? Where a and b are integer, is another way. The other way I can ask this same question is I can ask the same question as I will say rationalize. I'll just say rationalize the denominator. Rationalize the denominator. Yeah, Anna.
What's the difference between rationalize and conjugate? Like asking us to look for the conjugate of something.
Okay, good question. Please give me a minute.
Madam Anna, where are the rest now?
I don't know. I've sent it to everybody individually. I don't know. I cannot kill
Ah,
myself again. No.
you have really
I
tried,
sent it,
darling.
sent it to everybody's phone. So either way, yeah. Let's make do with the time.
Abby.
Okay,
I will
so
really
sorry. So Anna asked a question, conjugates, difference between conjugates and rationalization. That is a very important and very interesting question. So for every binomial sort, if you see my problem now. Somebody's asking question, I'm bringing a new word again. Don't mind me. Don't mind me. But I have to mention the word before we can continue. There are sorts that are called binomial sorts. Binomial sort means a sort with two terms. So this is a binomial sort, 7 plus root 5. This is another binomial sort, 3 plus root 5. Any sort term, in fact, this is a binomial sort, a plus b root 5. Any sort expression with two terms is referred to as a binomial sort. So any binomial sort that exists in this life has a conjugate. The conjugate of this binomial sort, 7 plus root 5, is simply 7 minus root 5. Just change this sign to negative sign. If it is plus, change it to minus. If it is minus, change it to plus. So it means that the conjugate of 7 plus root 5 is 7 minus root 5, while the conjugate of 7 minus root 5 is 7 plus root 5. Anna, does that answer your question?
Yes, sir.
So please, do we understand what conjugate means? Just change the sign.
yes, yes, to change the sign.
I have a feeling that Augustina is in kitchen. She's not paying attention. Let me ask her this question. Augustina, what's the conjugate of minus 2 minus root 3? I have a feeling that you're in the kitchen.
Yeah,
You see now, I'll catch her
yes,
now.
I am.
So
Yes,
you
I
see,
am.
you see that my spirit is not lying. My spirit
Okay.
is not lying.
What was the question?
You see, she's still asking what's the question again.
Sorry, sorry, sir. Sorry,
So
sir.
what's the conjugate of minus 2 minus root 3?
Oh, that would be -2 plus √3.
Ooh, let's celebrate. Let's celebrate Christina. She's correct. Ooh, I'll give you one candy. Don't worry. And Charity, please give Anna. I can see you're the closest to Christina Agostina. Give her one candy, please, for me. So she's correct. -2 plus root 3. That's the conjugate. So that is just it. Just change this sign. Don't I just added this one to see if I can confuse her. But she's smart enough to see my trap and not even change those sign. So ignore the sign that has that of the first number, but focus on the sign that combines the two terms. Okay, let me ask this last question before before we move further. Olakunle, please help me. What is the conjugate of 3 root 5 plus 2 root 7? Olakunle, what's the conjugate of 3 root 5 plus 2 root 7?
That's 3 root 5 minus 2 root 7.
Beautiful. So that's the conjugate. That is just it. Very straightforward. So I believe now everybody on this call plus Anna understands what we mean by conjugate of a binomial sort, right? Just give me
Yes,
reactions
Sure.
if
sir.
you good. Let's now go ahead. Let's continue. So that is conjugate. Now, when we talk about rationalize, to rationalize, you will need the conjugate to actually rationalize any fractional or rational binomial term. Okay, like I said, this question that says express this rational sort in the form of this can also be a question that can be asked in a different form just by saying rationalize the denominator of the given binomial fraction. So let's see how to solve that problem. The way to solve this problem is to multiply both the numerator and the denominator by the conjugate of the denominator. I'll say that again. Whenever you are solving a problem of this kind, or if the question says rationalize the denominator, remember they are equivalent, right? They're the same thing. The first step to take is to multiply and the denominator by the conjugate of the denominator. If you understand what I said, please give me thumbs up. Anna understands. Just Anna. Oh, wow. Oh yeah, Anna, please help others. So it seems they do not understand. Can you say what I said again in your own word?
Mm, you said to rationalize this question or
Mm-hmm.
equation, we just multiply it by the conjugate of the denominator.
Yes.
What I got.
Please give Anna. Yes, it's correct. So I said to rationalize the denominator of any rational sort term, comma, multiply both the numerator and denominator by the conjugate of the denominator. Does that make sense? So this is the step I'm about to take. I want to multiply both the numerator and denominator of this fraction by the conjugate of the denominator. Mabel, welcome. Please, can you help us? What is the conjugate of the denominator of the given fraction? Mabel?
Good evening, everyone. I'm just coming in, so I'm trying to
Yeah, trying to
understand.
follow. Ah,
I'm trying to follow, so give me a few
okay.
minutes.
No problem. Call somebody else to help you with that question. Who do you want to call? Whose name do you like here?
Obviously, Hannah.
Hannah. Hannah for president. Oh yeah, Hannah, I should call you, help her out. Hi, Olabisi, welcome.
Sorry, I didn't get the question. The
The question is
conjugate of which?
of the denominator of the given fraction, of this fraction that is on the board, the
That's
question.
3 minus root 5.
Good. Maybe do you want to ask her why? Or you understand why it is 3 minus root 5?
Please explain.
Okay, Hannah, she says she explained, no, she doesn't understand why it is 3 minus root 5 because she just joined.
And I asked a question at the beginning of this class that what does conjugate mean? So you just change the conjugate of a number is the
No,
Negative.
no, please, before you go, please, let's use the right term. Let's use the right term. It's
Okay.
not conjugate of a number, it's conjugate of a binomial sword.
Sword. Okay.
Yes. Because a number, except you
Yeah.
want to say, if you say a number, that means you're saying, for example, 3. What's the conjugate
Yeah.
of 3? 3 does not have a conjugate, but 3 has an additive and multiplicative inverses. So let us go into that
Inverse.
now. So it's the right term. Yes. A
Okay.
conjugate of a binomial
So
sword. Hmm.
the conjugate of a binomial sword is like just changing the sign in the equation.
The sign in the middle of the
In the
two.
equation, in the middle.
No, it's not
But
an
sir, I have to
equation.
ask,
No,
is this an equation? It's
no,
not
it's not
an
an
equation,
equation. No.
right?
Yes. Mathematics is so stupid that there are a lot of terms and you must use the right term. You understand? That is math for you.
Okay.
It's like a language.
Just change
So
the
an
number
equation,
sign in the middle. Finish.
yes, yes, in the middle. So an equation is example of an equation. There must be an equality sign before it becomes an equation. So you can say this is an expression. Just change the sign at the middle of the expression. So if this is now, because this is plus, change it to minus. If it was minus, change it to plus. Do you get that, Mabel?
Yes,
So
very clear.
that is the conjugate. Beautiful. Now that
Thank you.
Hannah has given us the conjugate, we use that conjugate to multiply both the top, that is times 3 minus root 5, and the bottom 3 minus root 5. I know I'm taking a lot of time to explain this. That is how it is in math. By the time you understand the rudiments, the basics, any other question you see, you're able to solve. But if I just jump into solving this question without giving you reasons and explaining these terms, breaking them down, when you see similar question, you may not be able to solve it because it might not come directly as this one is presented. I don't know if I'm making sense. Please give me reactions if I'm making sense. Okay, Hannah, just Augustina. Augustina is back from the kitchen. Olakunle, Charity, Mabel, Lorena is not here. Ajibola is not here. Olabisi. Okay, maybe they will join us when they come back from market. Let's continue. So this is going to be what? This becomes 7. Now I want to bring them together. I'll put this in a bracket. You remember in mathematics, brackets also means times over 3 plus root 5 in a bracket and 3 minus root 5 in another bracket. So I want us to do this together. I don't want to solve all the problem by myself. I want us to do it together. Okay. Who wants to solve the numerator? Numerator is the ones at the top. Who wants to expand? Not actually solve. Who wants to expand the terms at the numerator for us? For a gift. I'll give the person one gift. I promise. T and C applied. Nobody. Nobody wants my gift. Okay. I'll hold my gift to myself and solve it and expand it. Okay, so this is how to expand these terms. So for understanding, let me do the expansion here. Okay, please watch. Uh God help me. I'm trying to see how best I can explain. Let me first of all use variables. So let's say we have two variables, A plus B and X plus Y, and I want to expand this. I would use this variable A to multiply the second bracket. So I picked A. I'll use A to multiply the second bracket, the entire element in the second bracket. Then I pick plus B, use it to multiply the same second bracket. So when you open the bracket, it becomes A times X, AX, A times plus Y, that is plus AY, then B times X plus BX, B times Y plus BY. This is the expansion you get. Now let's do the same thing with this sword terms. Let's expand it. So it means I will have 7. Okay, sorry, I don't want to do this one. So I've given an example. Who wants to now use the same example I just gave to tell me how I will expand the numerator? No, I'll not say who now. Let me call on Lorena. Lorena, are you able to unmute your mic? Okay, Lorena is not back from markets. Let's see if Ajibola is back. Hi, Ajibola, are you back? Can you help us expand using the example I just gave with the variables? Okay, no, Ajibola is not here. Let's see if Charity is here. Charity, can you do that for us, please? Charity had gone to the market to. Okay, Olakunle, can you please help us to? Okay,
Okay,
Olabisi.
let me just try, sir.
Yes, please try. Is that try that I want? I
I,
want you to try.
I just want to try. That
Yes,
will
please.
be
Let's do it.
seven.
Seven.
That will be seven,
Yes.
open brackets,
Yes.
um,
Three.
open bracket, three,
Minus. Uh-huh.
three,
Uh-huh.
um,
Minus root five. That is
plus,
it.
right? Okay, minus
So
root five.
yes.
Then,
So that means you pick this
then,
one and write this bracket.
yes, use it to multiply. Yes, sir.
Okay. Then I pick the next. I don't want to multiply yet. I pick
Okay,
the next one with the sign. That is
okay,
plus root five.
plus, okay, plus root five. We use
Then
it to
write
multiply
same bracket.
three. Okay,
Yes, 3 minus root 5.
okay,
Guys, that is it.
okay.
It is that straightforward. Is that
Hmm.
straightforward? Is that straightforward? That's the first step to take. Just use the first number in the
Wow,
first
wow,
bracket
wow, wow, wow.
and then the
Wow.
second bracket in front of it. Then pick the sign and the second number, then put the second bracket in front of it. That's the first step. We've not expanded here too. Let's do the same thing to the denominator. Okay, now that we have done the numerator, I need someone to do the denominator for me now. I will not even say anything. I will just allow the person to speak throughout. Who wants to do that for us? Going one, going two, going three. I'll call on somebody.
Okay,
Maybe.
let me
Okay,
try.
we're both in spirits. Let's go.
Okay, so 3
Mm-hmm.
open brackets,
Mm-hmm.
3 minus root 5,
Mm-hmm.
um minus uh,
Okay.
okay, minus
So what
root
minus are you
5.
looking at?
I'm looking
What
at
minus?
the,
This one?
yeah,
No. You pick this one because you pick three from here. Pick the
yes,
second element. So that'll be plus root
okay,
five.
plus root 5 open
Mm-hmm.
brackets, 3 minus root 5.
Beautiful. Guys, is it difficult at all? No, it's not.
It's not
It's very,
difficult.
it's very straightforward. So that is the first step. Now the next step is to expand. So let's expand just the way I expanded here, right? So I will please everybody listen, look at it very, very carefully. I'll do the first one, the one at the top. Then I'll call someone to do the one for us at the bottom. Now, how do I expand? I'll use 7 to multiply 3. This number outside, use it to multiply 3. So 7 times 3 is 21. I'll write it down. Then I'll use the same 7 to multiply minus root 5. 7 times minus root 5 is minus 7 root 5. You can't multiply a number by a sword and take the number under the sword. No, the number will be outside the sword. The only time you can multiply the number that is in under the sword, under the square root sign, is when both of them are having roots. So for instance, if I say have root 2 times root 3, because they are both having square root sign, I will give them a common square root sign and multiply the numbers together. The numbers will also be under a square root sign. So I'll have root 6. But if it was 2 times root 3, these 2 cannot go under the root. It will stay outside the root. It becomes 2 root 3. Please, do you understand that analogy and that explanation about multiplying two swords? I would like to see reactions. Okay, Augustina understands. All right, Hannah also understands. Good. So that is the reason why I got minus 7 root 5. So the 7 is outside the root. I don't take it inside the root. Let's look at the next term. So I'm done with the expansion of the first bracket. Now, I'll move on to the second bracket. Let's move on to the second bracket, which is this plus root 5. Now, plus root 5 times 3. Given what I explained above, who wants to answer that question? What is plus root 5 times 3? What would the answer give us? Augustina. Plus root 5 times 3 is what? Augustina. Ah, she's not here.
I'm
Ajibola,
here. I'm just thinking.
welcome back. Given the illustration above, when you're multiplying a sword and a number, the number cannot go under the root. It has to be outside. So what is plus root 5 times 3? Olabisi.
3 root
Okay.
5.
Good, that's correct. But don't forget the plus sign. Don't forget the plus sign. Plus 3 root 5. That's correct. Aha! Now let me see who will get this one correctly for a price. T and C apply. Plus root 5 times minus root 5. When you're multiplying two numbers with roots, because they both have square root sign, give the product a common square root sign. So what is plus root 5 times minus root 5? Ajibola. Okay, Hannah wants to try. Hannah, go
I
ahead.
think it's 5
5
minus 5. Like with the
minus 5.
three.
Wow. Ah, Hannah, I've gotten my gift. Augustina, you're the closest person to her. Please let me give her one candy. So Hannah is very correct. Is anybody here that wants to ask Hannah how did she get 5? Do we understand how Hannah got her 5? Minus 5 rather. Ah, okay, everybody understands.
No,
Anna, what do
no,
you
No,
sir. No,
we
I don't
don't.
get it, sir.
Okay, I thought you all understand. So Anna, do you care to explain how or why? How did you get minus 5?
You explained it earlier. I don't really know this mathematical terms is. I just know that when we are solving sod, when we have
Uh,
two numbers that are the same, we just pick
wow. Ah,
the
Anna has
number.
watched. Anna, she has seen all my videos in the classroom. Well done, Anna. I should give you a gift. So look at, I said it in the classroom, some of the videos there, that when you're multiplying sod with the same number, like for instance, root A times root A, because the number under the roots for the both sod, they are the same, your answer will always be A, just A. Ah, what happened? What's wrong with my pen now? Okay, oh, my pen had decided not to write again. Let me see. Oh, I think this pen is low. The battery of my pen is low. I will force to use my fingers to write. Let me charge it small. Okay, so this is going to be equal to A. So please mind my handwriting from now henceforth. The battery of my pen just went down. Do you see that? Root A times root A is equal to A. If I have plus root A times minus root A, use the same thing. First of all, say plus times minus, and plus times minus is minus. Since root A are the same thing, you have A. That is the same idea that Hannah has used here. She said plus root 5 times minus root 5, and the answer here is what? Minus 5, because plus times minus is minus, and root 5 times root 5 is 5. That's it. That's it. Please, is it fair? Is it fairly clear? There's any English like that? Because I know that it may not be absolutely clear, but I hope it's fair. Yeah. So that's the answer to that question, to that
Yes, sir.
particular simplification. Over now. Okay. So I said somebody will do the one for us at the denominator. Who wants to volunteer quickly? Who wants to volunteer so that we can quickly solve this question? Anyone? Okay. Olabisi, do you care? Do you mind volunteering?
Sorry, let me try.
Okay. Oh, okay. Oh, she can't. They can't unmute. Sorry, Olabisi. Yeah, go ahead, maybe.
So it should be 6
9?
minus.
No, 9. 3 times 3 is 9.
Oh, 3 times 3 is 9. So I was looking at 2. So it's
Okay.
9
Mm-hmm.
minus 3 root 5
Very correct.
plus 3 root 5
Beautiful.
plus 5.
Plus minus minus. Plus minus minus.
Oh, minus 5.
Minus 5. Great. Please let's give a round of let's give Mabel a round of applause. Well done, Mabel. That is absolutely correct. Now, the next step will be to simplify those short term. Let's add and subtract. We are done with the expansion. Let's now add and subtract. This should then be equal to collect like terms for the numerator. All the numbers without square root side, bring them together. 21 minus 5, then minus 7 root 5 plus 3 root 5. I could take them together all over. I just rearrange the numbers. 9 minus 5. Why? Because minus root 5 plus root 5 is 0. So that is taken off. Okay, we can now add the numerator. 21 minus 5 is what? 6. Minus 7 root 5 plus 3 root 5 is what? Who knows? Minus 7 root 5 plus 3 root 5 is what?
Minus 4 root 5.
Minus 4 root 5. That's correct. I hope you understand how we got minus 4 root 5.
Minus 7
Plus 3.
plus 3. So that's
Yes,
minus 4.
that is
Then
minus 4.
the root 5, just pick one.
Come on. Exactly. Good. So 9 minus 5 is 4. And that's the answer. But we can factor out 2. 2 is common at the numerator. You can, when you bring out 2, it becomes 2 into 3 minus 2 root 5 all over 4. And 2 can go into 4 two times. So the final answer is 3 minus 2 root 5 over 2. That's the final
Is
answer.
this supposed to be 6 or 16? 21 minus
Oh,
5.
sorry, 16. Thank you very much for the 16. Sorry. Sorry about that.
So from
I
me, I want to ask a question. Can we
please do.
use this 4 to now like divide like 4 in 16 for 4 in 4 1? I don't know. Can
Yes,
we
you
do it
can.
like that?
Yes, you can. But that is not what we are doing. Yes, we can do that, but that is not what we are actually doing. So what we are actually thought out for, since 4 can go in both 16 and 4. 4 will go into 16 4 times, right?
Yes.
We bring out 4 outside. So 4 goes into 16 4 times, and 4 goes into 4 one time. That is 1 times root 5 is root 5 over 4. So this is what we're actually doing. 4 cancel 4. So the answer
Okay.
is 4 minus root 5. This is what we're actually doing. But what am I writing? But one can also say one can also say 4 in 4 1, 4 in 16 4, 4 in 4 1. But this is not actually the right approach to do it. The right approach is what I've done here.
Okay.
I hope that is clear.
Yes.
Okay, guys, so that's the answer. 4 minus root 5. Can see one question, although you know that it's so long, but because we're trying to explain some terms before we
So
solve. That
like
this
we are
one.
asked to express it in the form A. Okay, that's it. That's it.
We have expressed it. So here A
Yeah,
is
yeah.
4 and B is what? So what will be? A is 4. What is B? Yeah, who knows what the value of B is from the final answer we got now? We got our answer as 4 minus root 5. So I'm saying that the value of A is 4. So who knows what is the value of B? Or what would be the value of B? Nobody. Ah, okay. The value of B, okay, let me give you a clue. Let me give you a hint. The value of B is the coefficient of minus as God. The coefficient of root 5. What's the coefficient of root 5?
Minus 1.
Minus 1, correct. So the value of B is minus 1. Do you understand? Hello, are we here? Or has my network kicked me out? Okay, maybe we are here actually. Okay, are there questions? Any question from this problem that we just solved or other questions? Please ask if you have questions.
No, the explanation is clear, sir. Thank you very much.
You're welcome, sir.
Sir, I believe the record is still on, sir.
Yes, it's still on.
Okay, so that we can go over it again and again.
Sure, very important.
Yes, sir.
Are there other area of concerns or any question that you may have for me?
I have another one.
Yes, please, go ahead.
It's on quadratic inequalities.
Okay,
So after getting the answer, I'm having issues with combining the
the final inequalities.
yes.
All right, let me hear. Yeah, let me hear the question.
Okay, let's use this. 2x squared
I'm coming. So you say 2x squared
minus 3x
minus 3x
minus 5
minus 5
eh,
is it greater
greater
than or less than?
than 0.
Greater than 0. So, okay, this is another interesting topic in mathematics. It's called quadratic inequalities. I'll give you guys a hint on quadratic inequalities. Whenever you have quadratic inequality with any two brackets, let's say x minus a and x minus b less than 0. Whenever it is less than 0 like this, hmm, whenever it is less than 0 like this, the way you solve this problem is this. Listen, oh, this is a hint because your exam will come in form of multiple choice, OBJ or objective, and nobody is going to ask of your solution, your calculation. Let me see the steps. All what we are concerned about is the final answer. So when you're solving your exams, you are trying to find every possible the short method to solving those problems and getting the correct answer. So in quadratic inequalities, you will factorize and obtain an expression of this form. Whenever you get to this particular point, it's usually very technical to how to getting the final answer. So I want to give you a clue of how to get the final answer when you arrive at this point. At this point, when it is less than, please take note to when the inequality is less than, either less than or less than equal to any of these two, it works the same way. This is what you do. You bring the expression in the first bracket, x minus a, equate it to 0, solve for x. Bring the expression in the second bracket, x minus b, set it to 0, solve for x equals b, right? Then compare the two answers. Compare A and B. A and B. If if A is less than B, if A is less than B, then your final answer to the inequality you solve should be A less than X less than B. But if B is less than A, then your final answer to the inequality should be B less than X less than A. Please, do you understand this illustration, this explanation? So I'm using A and B, I'm using variables. Don't worry, we solve this actual question where we use numbers. But whenever it is less than sign or less than equal to, when you factorize the expression, you have your factors. You fact the factors less than 0, set each of the expression in the bracket to 0, and compare the answers. If A is less than B, then the first inequality should be your answer, A less than X less than B. But if B is less than A, the second inequality should be your answer, B less than X less than A. Now, this is for less than sign. But if it is greater than sign, like the one we have in this question, so if you have something like x minus b, sorry, x minus a, and x minus b, and x minus b greater than 0. So if it's a greater than sign like this, do the same thing. Take the first expression, set to 0, and solve for x. You get x as a. Take the expression, set to 0, and solve for b. You get x as b. You have to also compare A and B. Compare A and B. So if A is less than B, then your answer to the inequality would be um, x less than A or x greater than B. Do you get it?
No.
You don't understand? If A is less than B, then the answer to your inequality would be x less than the smaller number. or x greater than the bigger number.
Okay.
But if b is less than a, if b is smaller than a, then your answer would be x less than the smaller number, which is b in this case, or x greater than the bigger number, which is a in this case. So whenever it is or, so I'd like you to note down these things we just explained. We use them to solve this question, but this time around we are looking at this case where the inequality sign is greater than sign. Can I clean the board and forge ahead? Can I clean the board and forge ahead?
1 minute. X. X.
Can I forge ahead?
Yes. For my end. Yes.
Okay, yeah, others, can I forge ahead, please?
Sir, go ahead. Go on, sir.
All right, let's move on. Now,
So, sorry, before you move on, okay, I want to say first and foremost, thank you for class so far. I've been trying to listen on the ground. Your teachings are very, very simple and straightforward and easy to understand. So I don't know if you can perhaps just do a recording, please, so that we can revisit.
yes,
Because at the
we are
moment from
recording.
my end, the screen is being recorded. Thank you so much.
Yeah, it's being
I'm just
recorded.
trying to
Yes.
multitask at work. I'm still at work.
Oh, sorry. Please make the money for us, please. Make the money for us. At the end of the month, ask for account number. Okay. All right. So
No
without me
So,
just
problem.
sorry,
speaking,
sir.
Sorry, Chama.
Sorry, sir. Hello, sir.
yes.
I have something to say, sir.
Please go ahead. Let me hear you.
Actually, I am having issue with mathematics, but
Oh.
with the way you are, treating it now, I
Mm-hmm.
did being if the way you are treating it now is very simple, sir. In the
Yes.
sense that you are explaining the terms, you are explaining the language step by step.
Who is laughing at
I
Mr.
did it's a
Olamide?
regular class now. I did
Eh?
it's a
Miss
regular class
Lorena
now.
is laughing at Mr. Olamide.
You said I did it's a regular class now. All
Uh,
these things, it will just be like magic.
I'll
So
tell you
I
what.
want to suggest, sir. I want to
Uh-huh.
suggest, sir,
Uh-huh.
if you can just do a recording for us of mathematical language and explanation rules. Because if we are able to get all those things, math will be very simple. But because
Yeah.
the background will lack the rudiment and the terminology and the rules, that's the reason we're having issue. So I think
Yes.
we need another recording whereby step by step of certain issue that I explained. I think that will make maths easy for us because to me, it's not the issue of passing this course. I believe we are
Yes.
going to pass, fine. But
Mm.
is solving the problem from the root is more important to me.
Yes. I agree with
So
you.
please, I try to consider that, sir, or just try to produce a textbook or a video. We'll buy.
Um, excuse me, sir.
Yes. Everything I
Can I
can hear
just
you.
add one thing? To
Yes. Please go
second
ahead.
what Olamide is saying.
Go ahead.
Last semester before they dropped mathematics, I was thinking to myself that if after the way you teach this course, somebody still have questions or you don't understand, then that should
Uh-huh.
even be a crime. So I do honestly, I feel like if I've had you as a mathematical teacher from back when, it would have been an easier subject now, but it's not. But one thing I do
Uh-huh.
remember is that somebody asked you if it was possible, if you can like organize, even if it's like a paid tutorial outside of Miva. Someone
Mm-hmm.
asked you in one of the live session, but I think you said you were gonna think about it. And since we dropped the subjects, we never really got your response. So
Oh,
is that would that be something you'd be willing to
Ah,
proceed now,
please.
please?
Okay. Yeah. Yes,
yeah.
please let me add though, please.
Please go ahead.
Mr. Augustine, we cannot pay him. Oh. He charges in dollars. So do you have dollars? We can only compensate him. We can only
How do
just
you?
show our
You
appreciation,
know,
You
say
correct.
thank you for your
You are
time.
have
correct.
you
Oh.
cons-
We
have you
cannot pay
have you
him. This one
consulted
you
Let him
be that
talk.
before?
Let
saying
him
pay
let him
tutorial.
say
How
what.
do you
Let
want to
him
get the
reply
money to pay
first.
him?
Dollar is high.
Please.
Oh.
We
Dollar has
cannot pay
gone up.
him.
Oh.
Wait.
We can decide to
Uh,
compensate him by contributing money to buy him a phone or a laptop or buy him lunch or subscribe
I don't know.
data as our power
Have you?
carry. Imagine we'll be
Sister,
four
you
of
know
us
how
on this
much a
call. You are
laptop
saying
costs?
pay.
Do
Pay
you know
what?
how much a
No, I'm
laptop
You
just
costs?
saying
you
now.
you guys are
I'm
just
just saying, even you that you are talking, I don't know how your capacity. Maybe you're a CEO to five companies now. I don't know. Do you get?
Oh,
So I
in
cannot
Jesus' name,
underrate you.
amen.
Do you
But let
understand?
him talk. You
Yeah,
would not
so
even let
that's
the
that.
man reply. You
Yes,
know, maybe
so
it's
government
like
is rich. We should bill her very well.
Anna, stop.
All right. Thank
Bye.
you very much for everything you guys said. I want to first ask Lorena, how do you know? Have you interacted with any of my clients before? You people are very smart. So you just knew that I charge in
I'm
dollar.
not. Oh, it's my first time hearing you teach.
Oh my
Self.
god.
It's my
Oh, but
first time
sincerely,
hearing
I
you
follow
teach.
you on LinkedIn, so I have a
Whoa.
suspicion. But that's
Uh-huh.
notwithstanding. It would be nice to
Nice.
hear from you.
Nice. Thank you very much. Thank you very much. Yeah. So let me start with Mr. Ola Kunle. Yes, you said it right. It's just so math actually is a language. That is the truth. The way you learn, I just connect it with literally. Imagine you want to begin to learn French for the first time. What would you start with? You want to start with sentences. You can't start speaking. So you
Hmm.
have to start with the alphabet,
Yeah.
and you learn how they pronounce it, not just knowing the alphabet, you must know even Yoruba. For this of you that Yoruba people here on the call, I stayed in the West, so I knew how I learned the small Yoruba I know how to speak. I know how to speak. You would see a one word, the same spelling, but different intonation. That word will mean different things, right?
Hmm.
Am I correct, Olamide?
Yes, sir. Yes, we are right, sir.
Good. So that's intention. That's where you learn languages intentionally. Same thing you learn mathematics. You have to begin number one with the symbols, with the way what they mean. Because one thing in math, for instance, let me give an example. In math, in calculus, if you see this, it means y prime in calculus. But in set, if you see this, it means complement of y. There are two different things, but you see there is the same symbol. You say the same symbol, but they mean two different things. In calculus, y prime means the derivative of y, the derivative of y. In set theory, it means the complement of that set. So you have to understand the language and the symbol and what each of them mean. But unfortunately, we do not have that amount of time. While shooting my videos for the live session, I mean for the classroom, I tried my best to break it down, but I have limitations. Why? Because we have limited number of videos we can actually shoot because of production. Number two, because of the time, and then number four, because we have syllabus to work with. So I totally understand that the people that are coming to Miva to learn this course, they must be advanced people that have gone to school for years, like they've had first degrees, some people second degree, some people we have PhD, we have professors as Miva students taking courses. So imagine those people that have done elementary math in secondary school for like about 20 years ago, and they're coming back to school. So I knew that we had those class of people, and that was the reason why I tried to simplify concepts. But even with that effort, I know it's not enough, right? So that answers the angle of why we didn't have enough of such. Okay, and then going forward, so why am I not able to simplify, break it down like this during our usual life lessons? It's because of the limited time also. 1 hour, imagine 1 hour to teach math. Now look at the question, the first question we solved. If you're looking at the time, it took us almost 1 hour to solve that question. Not because the question is difficult, but because I had to explain one concept, break it down, make sure
Hmm.
everybody understands before I apply it. If
Hmm.
I don't do that, it means we just come here to waste our time. because you see me solve
You are
it,
correct, sir.
but you will not
Hmm.
understand why I am taking the steps. You
Hmm.
understand? So we don't have that time for normal life lessons. If I sometimes I try to do that, but most times people will say, in the class, all fingers are not equal. Some people are ahead. Those people that are ahead will be vexing for me. I know in my mind. They'll be saying, this man is just saying small story. Because they vex, because
Hmm.
I'm also that kind of student. If I'm in a class where a lecturer is trying to explain and explain and explain, I mean, I have read ahead of time. I'll just be vexing for that lecturer saying, this man, you see they do. Go, 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 go. But there's some people there that are appreciating that explanation and again and again. So we're not able to do that. But some in a meeting like this, I can do that because it's a meeting that somebody actually requested for. And I know that I shouldn't just come and begin to solve maths to show that I know how to solve maths. I should break it down and for everybody to
Hmm.
understand. All right. So anyone that feels that okay, this man is coming here again to say small story, the person should leave. The person should leave because the person knows it already. He shouldn't be here. It's those people
Yes,
that need
yes,
help
so yes,
that are
so
here. So let us take
yes,
our time
so
to break it down. So that is the reason why we may not do that during live lesson. Okay, now to the final request concerning the what's it called meeting. So yes, I am open to having this kind of meetings from time to time. Though my schedule is very very tight, but anything that will help my students understand, like I'm somebody that I'm so big on understanding the concept and not just passing exams. Because if I did math in my first degree. If I read math in, assuming I read math the way I by just passing, I won't be able to explain math the way I'm explaining it now, and I would
yes,
not
you
be
are
able
correct.
to apply math as a data scientist. Today, I'm also a data scientist alongside a lecturer in MIVA. So I see the real application of mathematics in my day-to-day job as a data scientist. I will not be able to apply it. So I usually employ anybody who is learning math to know it, don't cram it, understand it. Because every one of us here, we are applying mathematics on a daily basis. No matter where you work, if you tell me, I will tell you how you apply math, but you don't even know. You may be applying it directly or indirectly. Maybe using a tool that leverages on mathematics to do your job, but you don't know. It is when you know you appreciate it. Okay, I've said so much stories. So having said that, when it comes to the tutorial, I am more than happy to meet with you guys anytime, provided it's not clashing with my schedule. You can tell me ahead of time, we'll meet, I would explain. But I am doing that for 0 naira. 0 naira. I'm not taking anything because I want my you've paid for your school fees already. This is part of the job we have called to do. So that's it. All right, having said that, let's solve this problem, right? Because of time. Let's solve this problem. I'll clean I'll clean all these explanations I've given and try to complete it here. Let me clean this one. So we're going to I believe we've written that down because I'm going to apply it in solving this problem. Okay. This is another so in solving this problem, I have to explain another concept. So please bear with me, because math is interrelated. You are solving one question under sword. You go to algebra and mention something. You go to factorization. So that is how math is. That is why you have to learn one level before another. Okay, so anyone that is struggling here is not your fault. It's because maybe you've forgotten some things you've learned, or you've not gotten a grasp of a foundation before going to the top. So when they are solving that one at the top, it becomes very, very confusing and that. So we have to factorize this first. An equation of this form, an expression rather, this is an expression. An expression of this form is called quadratic. Why is it quadratic? Because the highest power of the unknown. So the unknown in this expression is x. The highest power is 2. So anytime you see an expression whose power is 2, we call such expression quadratic expression. If the highest power is 3, we call the expression cubic expression. If the highest power is 4, we call it quartic expression. If the highest power is 5, we call it quintic. If the highest power is 1, we call it linear expression. Okay? linear expression. Now, each of these expressions can be broken down except for linear expression. We can break down a quadratic expression into two factors. Why? Because it has power 2. And these are the factors. This one and this one. So these two, they are arbitrary factors. They are just like variable factors. It's not any specific quadratic expression. But for this one, we can have two factors. But there's a condition though. I'll tell you the condition later. If it was a cubic expression, how many factors do you think a cubic expression would have? How many factors?
3.
3. Beautiful, because it's of order 3. The degree is 3. So there'll be 3 factors. For quartic, 4 factors, and the rest. So any quadratic expression that is factorizable, in fact, it has to be factorizable. That means it must have a factor. So just know that if you have this type of question in exam or anything that has to do with inequality, just know that it must be factorizable in any question you're solving in this program. Okay, it must be factorizable, because before you can solve at this level, before you can solve any inequality that is a quadratic inequality, it must be a factorizable quadratic expression. So this very one that I'm seeing on my screen is factorizable. So how do I even know? How do I even know? Because you should be able to tell if a quadratic expression is factorizable or not. So how can you tell if it is factorizable? Let me digress a little bit again. Please bear with me. I said this earlier that I might be digressing. There is a quantity called discriminant. Discriminant. Has anyone here on this call heard about discriminants? Be it English, be it math, in any field. Is this a kind of familiar word? Discriminant. To discriminate, right? Is it a familiar word? And nobody's interacting with me again. Oh.
It's a familiar also.
Yes, it's an English word, to discriminate. So in math, we also use that discriminate term in English to also discriminate quadratic quadratic expressions. But this time around, we now added NANT, call it discriminant. So we use it to classify a quadratic expression, whether it can be factorized or not. And this is the formula. D, this stand for discriminant, equal to b squared minus 4ac. If you solve this, if you simplify this expression, if you solve this expression and you obtain a positive answer that is a perfect squared, I'm calling another term again that might not be so clear. If it's a positive answer that is a perfect squared, who knows what perfect squared as? Perfect squares are. Who knows what perfect squares are? Anybody? Hannah, do you want to try for us? What perfect squares are?
Perfect square. And I think there are number that are divisible by 2.
Okay, those are even numbers. You tried.
Okay.
Yes, you tried. Those are even numbers, actually. Augustina, do you want to try for us? Perfect squares. Okay. Augustina decides, okay, her mic
No,
is on
sir.
now.
No, no, no.
She doesn't
I
want to
don't
try.
know. No.
Okay. Maybe do you want to try for us? Or I should just answer my question myself.
Please just go ahead and answer.
Okay. So perfect squares are numbers whose square roots are whole numbers. Any number that you look for the square roots and it gives you a whole number, that number is considered a perfect square. I'll give an example. I'll give you some examples. 1 is a perfect square because the square root of 1 is 1. 4 is a perfect square because the square root of 4 is 2. 9 is a perfect square because the square root of 9 is 3. 16 is another perfect square because the square root of 16 is 4. Is 5 a perfect square? No. Because if you carry your calculator now in your phone and you punch the square root of 5, you will get a decimal number. It will not give you a whole number, which means that 5 is not a perfect square. Oh, I don't have that calculator here. There was one calculator I wanted to share with you guys. But let me just show you one calculator. Please bear with me. I know I'm taking so much time, but please forgive me. This is not the regular class. I would see end this very soon. I know some of us we need to go because we are working. I want to show you guys my calculator so that I will just explain that perfect square and then we'll continue solving that problem. Can you see my calculator? Can you
Yes,
see
we
my
can see
screen?
it.
Good. So this is my screen calculator. Now, if I look for, let's say I want to get the square root of, this is 4, right? The square root of 4 is what? 2. Can you see it on my screen? The square root of 4 is 2. That means 4 is a perfect square. It is not 2 that is a perfect square, though. It is 4 that is under the root that is a perfect square. 5. The square root of 5 is, you can see it, a very long number, 2.236. So 5 is not a perfect square. 1. The square root of 1 is 1. So that means 1 is a perfect square, right? Let's try 25. 25 is another perfect square because the square root is 5. Is 10 a perfect square? Is 10 a perfect square?
No, no.
No, because the square root of 10 is not a whole number. So I believe we now know what perfect squares are. Those are perfect squares. Any number whose square root is a whole number is called a perfect square. So now, when you calculate the discriminant, if the answer gives you a positive number and a perfect square, that means that quadratic expression can be factorized. Let's quickly test if this can be factorized. And what is the value? What are the values of a, b, and c from this expression? You compare it with the general quadratic equation ax squared plus bx plus c. Sorry, there's no square there. Ax squared plus bs plus c. This is general quadratic expression. So the value of a would be the coefficient of x squared. The value of b would be the coefficient of minus 3. The value of c would be the constant. So which means that a here is what? 2. B is what? Minus 3. And c is what? Minus 5. Let's put this expression, these numbers inside the formula and solve it. Then we'll see what we get. If we get a perfect square, it means we can factorize that quadratic expression. If not, we can't factorize it. So d equal to what? B is what? Minus 3. I'll raise minus 3 to the power to the square and to the power of 2 times 4. A is what? A is 2. And c is what? C is minus 5. Let's solve this. Minus 3 times minus 3 is 9. 4, okay, 2 times minus 5 is minus 10. And 4 times minus 10, that is plus what? Plus 40. Okay. 9 plus 4 plus 40 is 49. Is 49 a perfect square? Hannah, Hannah, why is 49 a perfect square? Hannah is saying yes.
Yes, because
Because
we can find the square root. The square root is going to give us 9.
7. To give us
It's
7.
7.
So
Yes. Yes, give us 7. Thank you. No, thank you for trying. I love that. I love that. So that means it means that we can factorize that quadratic expression because we've gotten a perfect square. So let's now factorize. This is not part of the solution. So listen, all of these things I'm saying now, these are the things that you need to do in your head. As a mathematician, immediately I saw this expression, once when Anna gave me, I had already calculated this in my head and I knew that it is factorizable. If I did not get a perfect square, I'll just say, Hannah, you know what? Please bring on that question. Leave this one aside. Because if I attempt to solve it, I will confuse everybody here. It's beyond this level. You don't want to solve this question that is not a perfect square at this level, please. So let's just work with one that is a perfect square so we can factorize easily. Now we've confirmed that it's a perfect square. It means we can factorize it. Let us now factorize. Factorizing it is another ball game all entirely, but I will not explain so much because even myself, I need to leave this call now and attend to other things. But please listen carefully. I'll try my best to explain, but I might not digress so much on this one. So let's factorize it. Now to factorize it, the steps involved. First of all, multiply the coefficient of x squared by minus 5. So 2 times minus 5 will give us minus 10. Now you've gotten this answer. What do you want to do next? You want to think of two numbers that such that when you multiply them, you will get minus 5. But when you add those numbers, you will get minus 5. Sorry, when you multiply them, you get minus 10. But when you add them, you get minus 5. Can we think of any of those? Sorry, not minus 5. When you add them, you will get minus 3. I'm sorry about that. You get this one. When you multiply the two numbers, it gives you minus 10, but when you add them, it will give you minus 3. So think of the factors of minus 10. What are the numbers that when you multiply them, you get minus 10? 1 and 10 are factors, right? 2 and 5 are the factors of 10. Are there other factors of 10 again? None. So 10 has just 4 factors: 1, 2, and 1, 2, 5, and 10. Correct? So which of these pair of numbers can we combine such that we will get minus 3 when we add them? And those numbers are minus 5 plus 2. That is minus 3. Correct or not? Is that true or false? When you add
True.
minus 5
True.
plus 2, you get minus 3. Now, because minus 5
Yes,
plus
sir.
2 gives us minus 3, anywhere we see minus 3 in the expression, we will replace it with minus 5 plus 2. So I will repeat the expression: 2x squared. So instead of minus 3x, I will put minus 5x plus 2x. So this expression, when you solve it, you will get minus 3x. Okay. So I have replaced minus 3 for minus 5 and plus 2. Then I will write the last number, minus 5 greater than 0. Now, why do we have to do this? I did that so that I can make the three term expressions one term, two term, three term. I mean the third term, the first term, second term, and the third term. I have made it a four term expressions: the first term, second term, third term, and fourth term. And why do we have to do that? Why do we have to make it a four term expression? We need it because we want to do what is called factorization by grouping. So I will group the first two numbers and group the second two numbers. So we have two pairs. I have not factorized though. What I just did here is what's known as grouping. Now it is from the grouping that we will then do what is called factorization. So think of the first group. Look at the first group. What is common between both terms in the first group? What is common? What is common? You can see it. What
X.
is common? X is common. Good, good. X is common. So I'll factor out X. I'll bring it out because it's common. I'll bring one of it. So since one of the X is out from here, I'm left with just one X. True. We'll be left with two X here. Just one of the X. So no longer squared because I've taken one of the X's out. Then I've taken the X here out. So I'm left with minus 5. Is that correct?
Yes.
That's what it's
Yes.
called factoring. I factored the X out. In the second group, what is common? Nothing. Nothing is common, right?
Yes.
So whenever you don't see any common term, put plus 1. Just put 1 outside. So it's only one that can go into both of them. Then we have 2x minus 5. Now, when you look at it, these brackets and this bracket, they have the same expression. And must always have something like this when you are factorizing quadratic expressions. If not, if you don't have the same expression in the bracket, it means that the factors you've chosen are actually not correct. So you have to go and look for the correct factors. But because we have chosen the correct factors, we have similar expression in the brackets. They will add greater than 0. Now, since they are the same thing, pick one of it, 2x minus 5. Then the x outside and the plus 1 outside, put them together in one bracket, x plus 1 greater than 0. You can see we have arrived at these factors. So these are the factors of the given quadratic expression. That is what is called factorization. So I have broken one expression into product of its factors, 2x minus 5 and x plus 1. I've gotten two factors. Now that I've gotten two factors, let's now apply that rule I gave us earlier. And what does the rule state? The rule states that once you get the factors, solve for x in the two brackets, right?
Yes.
Let's solve for x in the first bracket. I have 2x minus 5 equal to 0. This means that x will be equal to what? 5 over 2. Is that correct? If you don't understand how I got 5 over 2, let me know. I'm trying to be fast now because of time. But if you don't understand, I will explain. Do you all understand how I got 5 over 2?
Yes, yes.
Okay, good. Now, I have gotten x from the first bracket. Now, let's solve for x from the second bracket. That is x plus 1 equals 0. So, this means that x will be equal to what?
Minus
Minus 1,
one.
right? X equals minus 1. Now, what is the next step? According to the hint I gave us earlier, after solving for x, what do you do next? According to the hint I gave us earlier,
So we
we
join them together.
compare
Compare
the x, compare the x's. So, in minus 1 and 5 over 2, which is bigger?
5/2.
5 over 2 is bigger. Now, also take note of the sign. The sign is greater than sign. So, since 5 over 2 is bigger, it means that I will say x is less than the smaller one, or x is greater than the bigger one. That's the answer. That's the answer. Just apply that particular hint I gave you. So, since minus 1 is smaller, you will write x less than that smaller one, minus 1, or x greater than that bigger one, 5 over 2. That is the answer.
So how can we express this in a number line? On
In a
the
number line, on a number line, do this. There is 0 in between. There is minus 1 somewhere here. There is 5 over 2 here. Then x is on minus 1, faces the left location because it's less than sign. Then x is on 5 over 2, facing the right location because it's greater than sign. This is the expression on number line. And on interval, to express it on interval notation, this is the answer on interval notation. It's going to be um, open bracket infinity comma minus 1 open bracket union open bracket 5 over 2 comma infinity. So this is minus infinity. The first one is minus infinity. Then infinity. So this is interval notation. This is number line. This is inequality representation. So you have to know how to represent them in any of these ones because these are similar exam questions. You might be told to represent on an interval notation or on number line or in inequality. All right, you spent almost 2 hours, right?
no, just 1 hour
No, I
20
said
minutes.
no, I said almost. No, I didn't say 2 hours. I said
Okay.
almost.
Okay.
All right. Thank you, thank you, thank you. I hope this time we spent is actually we spent the time wisely and we spent it well, right?
In fact, the little I've learned, I'm happy.
Okay. Thank you. I'm also happy that at least some of us have learned something new. Okay.
Thank you
Hannah,
very
thank
much,
you.
Please
sir.
kindly help us share the record.
All right, I will share it. Okay,
Yeah,
please,
I'm
for me
not
to be
able
able to
to
share the
access the
recording.
record.
Okay, I will share it with Hannah. Hannah will share it with everyone who wants to see it. So, please, please just thank Hannah for organizing this. Hannah, thank you for putting this together, and
Thank you,
thank you everyone for.
Anna.
Madam Anna, thank you. We appreciate you. We love
Thank you,
you.
Anna.
Thank you.
You're welcome.
Oh,
Thank you
saying
for
make sure
coming
your
to
thing is
sir.
going to be
Thank you for
posted.
honoring our
And
invitation.
Anna, will you post it in the basic math group?
You're welcome.
All right. Bye
Hello?
everyone, and you can always
Thank
organize
you,
this
sir.
yeah.
I was
Just let me know
asking
ahead
if
of
you want
time.
to do
We really
You
appreciate
have a
you, sir.
wonderful day, everybody.
We
Yeah,
really
Thank
thank
you
you.
very much,
appreciate
sir.
you. Thank
We're
you.
grateful.
Very God bless you.